Thank you. Yeah, my name's Arno. I'm looking forward talking about 3D maps. I work for Esri, so let me ask, how many of you have heard about Esri before? There's a few, very little in fact. It's a pretty large company. It's market leader for geospatial GIS software. It's located in California. It's been around for quite a while, 50 years this year. We're celebrating the anniversary, which is unusual for a software company. But luckily for us, they have an R&D here in Zurich, where we specifically focus on 3D GIS applications. One of the products that we develop here in Zurich is a mapping API for JavaScript, a 3D mapping API. It supports 2D and 3D maps, but here in Zurich we specifically focus on the 3D part. It allows you to build web applications containing a map, obviously. These can be full screen maps covering the whole browser window where most of the user interactions are on or at least around the map. But it also allows you to simply integrate a map into your regular website and show something simple like the directions to a location or a store. If you want to know more about the API, developer page is definitely a good place to start with a bunch of samples, tutorials, and documentation. Another product we develop here in Zurich is the Scene Viewer. It builds on top of the API. It allows you to use the API's functionality through a UI. You can create, author 3D maps, which we call scenes. And it allows you to store them and share them with others quite easily because it is a publicly accessible web app. Another thing we do in the R&D in Zurich, me and a few coworkers together, is we actually take vacation together and we go on sailing trips. So it's usually 8 to 10 people. We get a boat together. It's a great way to discover a new place, visit a new place, and believe me, it's also a really good way to get to know your coworkers a bit better. Now, if you ever organize a trip like that, you probably know that it can be fun, but also a bit challenging to plan a trip for a few days, for a few people, and in that case, it usually helps to create a map. So we're going to do this together. We're going to plan our trip, a sailing trip, using the API. So the first thing we're going to do is we start with a base map showing a satellite. And using the API, it's as simple as instantiating the map, telling it to use the satellite imagery for the base map. And the next thing we have to do is tell it in which container, in which DOM element we want to render it. In this case, it's a full screen, covers the full screen. So that's all we see for the moment. In the last trip we did, we actually went to Greece, to the Cyclades. So we can either zoom in using the mouse, the scroll wheel, but we can also tell the API to do that for us by simply providing a coordinate and a zoom level, and it will automatically zoom into the place where we're going. Now for our trip, the next thing we want to do is map out the route, and that's also fairly straightforward, is we give it a few coordinates, a line style, and we already have a plan or an idea of where we want to go in our next trip. In a similar matter, we had a few stops on the way, so people know where we're going to stay overnight. And because it's a web app, we can easily share it. We can send it to people, to the crew, people joining the trip, and they have a chance to investigate the location, see what's going on there, prepare themselves a little for the trip. Now, fast forwarding a few weeks, we've gone on the sailing trip. We probably did a completely different route than what we planned, either because of the weather or people in the crew not coping with the waves very well. But what's certain is that we're going to come back with a bunch of pictures from that sailing trip. And because we want to share these pictures, show it to people that we're telling about our trip, all of a sudden our planning map becomes a review map. And it helps us to kind of point out where those pictures have been taken on the way. Now, what would be nice is if we could somehow go along that sailing line, that sailing trip that we mapped out at the beginning, and on the way show those pictures where they have been taken. Now, that's something that where tools are out there. This is a nice one, Polar Steps. It allows you to write a blog, put some pictures in, and associate that with points on a map. Excuse me. And I find it a really nice feature because if you just have text and pictures, you're always kind of wondering, okay, where is this really taken? And where has this picture been taken exactly? And this allows you to really find out where the person has been. It's also a nice tool if you're going on a longer trip to kind of keep your people back home informed where you are. Now, going back to our sailing map, let's see how we could possibly do something like that ourselves. And also, for the sample that we're going to create, we want to put a little more emphasis on the map and use some of those API capabilities that we have. Now, as the first thing, can you guess what we're going to do? We're going to replace the 2D map with a 3D version, which is, in fact, quite similar. The only thing we have to do is replace that map view we originally put in with a scene view. Remember, scenes is the name for 3D web maps. And also on the map itself, besides the satellite imagery, we have to give it some elevation service where it's able to query the altitudes, so it's able to draw terrain. And what we get from that is really already a map where we can tilt and zoom in and zoom into these islands. And instantly we get a bit better picture, better idea of what the shape of these islands, what they really look like in reality. And we realize that they're actually not only flat as they originally look like, but they're actually mountains coming out of the water. In the same way, we can do the same navigations as before, zooming in, except on a 3D map, of course, it's not just a two-dimensional coordinate, it's actually a camera object consisting of an altitude and a direction the camera is looking at. You also notice that the lines that we originally drawn, they're still there. They still work in 3D the same way they did in 2D. So we basically get that for free, drawing these lines. Now, why would we draw a 3D map? There's a few things that speak for it. First of all, we live in a three-dimensional world. So for us, it's natural to see things in 3D, and it's easier for us to navigate and know where we are in a 3D environment. Also, if we want to visualize anything with elevation, like these islands, it's really hard to do in a 2D map. It's just more natural in 3D. And of course, a third point is also that generally 3D maps are just more engaging when you show them to other people. However, in this slide, sorry, I just realized there's a mouse pointer here on the screen. Let me get that out of the way. So what we have here is satellite imagery, and the problem with satellite imagery, although it looks very realistic and allows you to really zoom in and see what the place looks like, it contains a lot of information that can be distracting and maybe distract from pictures you want to show or generally just what you're trying to visualize. So we're going to go ahead and replace this with a topographical map. Straightforward, where we just tell the map to, instead of using satellite imagery, to use a topographical map. Esri provides about 10 predefined maps like that. But the nice thing is they come in vector data. So you can actually change them in the front end by replacing the colors or emphasizing certain features like streets or names, labels, or not displaying them at all. However, for the sailing map that I'm going to do here, I really want to focus on the 3D aspects. Use the 3D capabilities of the API to really render these islands in a way where you understand what the shape and what the outline are. Now, if you start to create maps like that, you actually realize that a lot of the data that you need to do these kind of visualizations is publicly available in the internet. One of those data sets are contour lines. So I have to say that sometimes you have to pick the right terms to actually find that data. But in this case, there's a nice website that draws these contour lines for us and also allows you to download them. Now, contour lines is something you've probably seen on a hiking map. They help you to understand where exactly the elevation changes and how much. So in this case, we're actually looking at Zermatt, and you have the Matterhorn on the left. Maybe you noticed, but because it's a 2D map, it's not that easy to see. But what we can do is we can take those contour lines, go back to our map, and we can import them as a GeoJSON layer, which is essentially a vector format. And we're not only going to draw these lines as we've seen on the map before, but we're going to tell the API to draw them as extruded polygons, making them 3D objects with a certain height. And all of a sudden, we have the same islands agreed. They're visualized in maybe not the most realistic way, but they actually represent the elevation of the islands correctly. And we can still use the same 3D capabilities like we've seen before with rotating and navigating in the map to really explore those islands. Also, the sailing trip we previously mapped out is still there. We're adding a few effects like elevating it a little bit from the surface of the water so it throws a shadow. We gave it a bit of a different color. And if we add a little bit of JavaScript, some animations, some math, we can actually interpolate these lines and really draw out the sailing trip that we did. So that's cool. That looks nice. I think it will also look good if we put some pictures next to it so it doesn't distract too much away from the actual pictures that we're trying to show. However, we still have the question, so what do we do with these pictures in the map? We could put them side by side as we've seen before and somehow find a way to show the pictures on the left and navigate through the map. We could probably also put them in the map and somehow allow the user to click around and explore the trip that you did. But it's tricky with 3D because often, especially if you're on a tablet or a smartphone, people can get lost navigating. Or also, they might get lost just exploring your map and kind of going away from the original story that you're trying to tell. In this case, it's a very linear story where we start at some place and we visit a few islands, and we really want to guide the user through that story. So a technique I would like to show here is where you still have the regular content as you would have it in a blog post, and you can scroll through that content, but now you actually hook up the scrolling to the effects and to the map that you're displaying. And this allows the user to just scroll through the content as they usually would, but then in the background, you play all the effects. And it allows you to switch back and forth between text, images, and then more complex interactions on the map together with animations. Now, what looks complicated is actually not that hard to do. It's a technique that people also call scrollytelling. And it comes really down to 3 ingredients. One is, okay, you gotta hook it up to the scrolling of the browser. So for each element or each section of your content, you basically listen to what position it is. You get a value out of that between 1 and 0, and that you hook up to your fading effects or your animations. Second ingredient is a CSS property called sticky for the position. And the nice thing about that one is that it keeps certain elements for a certain while in the viewport while you continue to scroll. And that's important because often if you have animations, you don't want to have the scrolling and the animation at the same time. It's just too confusing. So that really allows you to keep the map at a certain place while you continue to scroll while you continue to navigate through your animation and still seeing the map at one place. And then the third ingredient is you probably don't want to have the user accidentally click into your map and interfere with these camera animations. So you can disable this by simply disallowing any pointer events on the canvas. So we can hook up other animations, like the camera animations, to the scrolling. And we can even draw lines going over the island while we scroll through the pictures. Now, this is a nice effect because it really works on every browser. If there's something that all the browsers do the same way, or more or less same way by now, it's probably scrolling. So you're not interfering with it in any way, you're really just listening to where it is. So this will work on browsers, will work also on tablets. Now, even if you wanted to let the user interact with the map, you can. At certain stages, you could at any point in time scrolling through this content by simply taking away this pointer event statement in the CSS, and the user can immediately start to interact with the 3D map again. So that's cool. At the basis of all this, so it's not only the scrolling that works across all browsers, it's actually WebGL, the underlying technology, which by now has been around for quite a few years and is supported by all major browsers and also all devices. So the scrolly telling that we've just seen is something that you could potentially also put on a cell phone in a responsive, with a responsive design, and it would work quite well there. Now, you probably don't want to implement the map by yourself using WebGL directly. Drawing a triangle with WebGL takes about 50 lines of code. It's very low level. So there's a bunch of APIs which do all the heavy lifting. Ours is one of them. There's new mapping APIs appearing every now and then, so it's a very popular space. And also there's libraries like 3JS, Babylon.js, which you probably have heard. They're not mapping specific, so they're 3D, general 3D rendering libraries for the web, and they also allow you to do things like games or just general animations. So, besides visualizing islands, another very important use case of our API are urban visualizations. And there's some amazing things that you can do in the browser by now. So if you do have aerial imagery, you can actually render a whole city in a browser, and it works quite well. It's impressive, but sometimes you don't actually need this kind of detail for whatever you're trying to do. And in fact, if you would want to use these kind of imagery, it's not that easy because, first of all, they're most cases not public, and they can be somewhat expensive to acquire. What is more common is that you have 3D city models, so that the city publishes their 3D models as buildings, and they're quite easy to import into your map if they're public, and simply render it in a map. So that's nice. What can we do with these city models? One thing is we can use them for visualizations. For example, here in San Francisco, we can color the buildings depending on the distance they are away from public transportation. And again, this is a very nice use case of 3D, because if you're looking at a certain building or apartment and you want to know how far it is away, it's much easier to find where you are in a 3D map. But there's more. So besides realistic rendering of cities, we can also do very artsy things by, for example, removing the base map and only drawing the edges of these 3D buildings, of these 3D models. And all of a sudden we get something that at first sight looks like a picture or a drawing, but in fact it's a 3D scene where you can navigate around and explore the city in a different kind of style. You could embed this in your website, and for example, make like a historical theme out of it. This project is open source. It's on GitHub. A colleague of mine implemented this, Raluca. She does amazing things with the API. She really tries out some of the boundaries. And if you want to see more, I really suggest that you go and check out her GitHub account. So if you look at how this is done, there's a special effect that allows you to draw the edges of the buildings in a sketched way. So it's not a straight line. It actually looks like it's hand-drawn. And you can play around with that, for example, by replacing the colors to make it look something like a drawing on a chalkboard. On top of that, and this is really interesting, is if you really just have a single 3D object or single 3D objects in your canvas, you can actually also apply CSS filters. And this was kind of surprising to me because I thought the canvas, the WebGL canvas that we have in the browser is somehow this enclosed area where magic happens and there's no interaction between the rest of the DOM or CSS properties. But applying a shadow to this building here actually allows us to give it a sort of a glowing style. So I found that quite interesting. Now, what can we do with these kind of visualizations, city visualizations? Another project that we did is the Manhattan Skyscraper Explorer. It colors the building in Manhattan, New York City, depending on their age. And it allows you to explore the city and kind of find out at what areas the age of the buildings are, and also filter them accordingly. Now, this project here is open source. It's on GitHub. You can go and try it out yourself. And you can also fork it. You can take the source code and you could try it out for your own city. And this is exactly what the city of Zurich just recently did. So they took the project, they imported their own buildings. What we're seeing here at the bottom is actually the building right next to us. It's a shopping mall. They renamed it from skyscrapers to Hochhaus, high rises. Obviously, in Zurich, everything is a little less tall than in New York City, so even the shopping mall next to us counts as a high rise. But besides that, so this allows you to basically go and see what kind of high rises are in Zurich. But besides that, they not only included current buildings, but they also added future buildings, plans of future buildings that you can see on the right. So in this case, we're looking at a building that's planned for 2024. Supposedly, it's going to be the highest building in Zurich. And this is nice because it's also a publicly accessible app that allows the citizens to go and have a look at what is planned in the city and also find out whether or not they're affected by these new plans by navigating or even zooming into their own place where they live and see if they can, if this changes their view from their perspective. So one more topic I would like to talk about is 3D user input. So far, the examples that we've seen, the islands and the city visualizations, they were all examples where you received information, so you're just consuming what you see on the map. But in fact, we can also use mapping frameworks to import information, to enter information. So in this example here, I'm basically telling the API to let the user draw a geometry, in this case a polygon on the elevation and close to one of the lakes here in Switzerland. Besides geometries, we can also draw 3D symbols into our scenes, place them, resize them, move them around. The API comes with a bunch of predefined symbols, but you can also import your own if you have them in a GLTF format. GLTF is an open format for 3D symbols, and that allows you to import your own symbols into your scene. So what can we do with that? This is another open source app that we've created in the R&D, and it basically allows citizens to do participatory planning. Now, what does that mean? So whenever the city plans to redevelop a certain area, build new houses, maybe new apartments or stores, it usually has to involve the community, the citizens in some way to gather feedback. Now, with an app like this, the citizens can not only provide feedback, they can actually also create their own proposals of what such an area could look like in the future. So, using the same techniques that we just saw before, drawing geometries or placing 3D symbols, we can actually draw streets, we can create parks, simply giving them a green or blue color for the water. By extruding some of the polygons, we actually get houses. So this is the same effect we've seen on the islands with the contour lines. And by placing symbols, you end up with a complete plan for a redevelopment area like we see here in New York. All right, that was it. I hope you liked it. I hope I raised your interest for creating 3D in the web browser. If you do, I would really like to see it. Even if it's just a prototype, please share it. I always like to see and hear what people do with our API. Thank you.